and welcome to today's training session. On the new Daikin FW range ducted chilled water fan coil series. We're going to look at the general points of the unit, some features, the control options for the range, as well as some reference sites. So let's look at some general topics about the background to this unit. Some Daikin and McQuay fan coil unit milestones. In 1917, the first classroom ventilator was installed. 1940, the first fan coil unit supplier. 2012, the first generation digitally commutated brushless fan coil unit, or inverter in layman's terms. In 2016, the first variable frequency compact fan coil unit, and in 2020, the new generation digitally commutated brushless fan coil unit, which is what this presentation is going to touch on as well. If we have a look at our product lineup, we have the inverter model, which is the DCBL, digitally commutated brushless option, from 340 to 2,300 cubes an hour, capacity from 2.2 to 13 kilowatts. These are the low ESP units. Then we have the medium ESP non-inverter range, going from 16.2 up to 18 kilowatts. Then we also have the high ESP for the long duct runs, giving us up to 38 kilowatts and up to 5,000 cubic meters an hour. The coils, generally 2-pipe with 3 rows. Here for the better latent heat removal, we go for the 4-row. Then from the FWWH range, we have the 4-pipe, so that would allow for hot water and cold water, as well as the 4 rows for nice dehumidification. And then the high ESP 2-pipe with 4 to 6 rows for some very good like fresh air applications where you need a lot of dehumidification. We have some good ESPs, 50 pascals, right up to 150 pascals. The water coils have all been tested up to 1.6 megapascals of dynamic water pressure. And the ESPs, generally just a background for ESP, it is your external static pressure. That is the work your fan has to do against static water, air molecules in the ductwork. So that is the work that the fan has to do to overcome air molecules that aren't moving, as well as friction on the ductwork. So generally, as a rule of thumb, the pressure drop in a low velocity ductwork system is normally around 1 pascal per meter. So here you can see the high ESP units can really do on high fan speed quite a lot of work against static air molecules and friction and bends of ductwork. There's also some very good certification, ISO 9001, ISO 14001, the AHRI certified, as well as Eurovent certification for these fan coil unit ranges. So let's have a look at some features on these units. They are high efficiency units due to the heat exchanger designs, as well as the inverter fan coil unit option. Stable and reliable, which is due to high quality materials and strict quality control at factory level. Low sound levels due to advances in noise reduction technology. and flexible installation allowing different options for water connections, either left and right hand side of the fan coil, as well as your return air ducting. We have reliability due to advanced manufacturing techniques. So if we look at the drain pan, for example, adaptive mounting bracket to avoid any damage to the insulation, sloped drain pans with good gradients for condense flow, a nice 37mm drain pan depth to avoid any buildup of condensation spilling over the sides, as well as a standard 7mm insulation in the drip tray. We have automatic welding for increased precision on the heat exchangers, and the flanged end plates preventing copper piping being cut by sheet metal. So here you can see this extra rigidity, and it's bent and flanged, so it won't, with oscillations, cut into the pipework, creating water leaks. We have a look at some of the unique fan coil components. The motor types, we only have one model that comes with an inverter permanent magnet inverter motor. The rest are AC, your conventional induction motors, your AC motors, they come in standard 3-speed, and the inverter motor has up to 5 different fan speed settings on it. The bearings have been relooked at, and the factory are using low noise rolling elements, and they've also put anti-corrosive treatments within the rolling elements in the ball races. The impellers have been made of metal. They're forward curved multi-blade, adopted to implement low fan speed with the advantage of large airflow and generating low noise, hence the big squirrel cage motors. And the coils are bluefin coated aluminium with hydrophilic treatment and copper piping going through the centers as your carriers of your working fluid. Yeah, the hydrophilic is pretty much makes the water molecules not coalesce and that run off very easily off the surface, so it always ensures that there's no water acting as an insulation barrier, so you're getting high efficiencies with great delta T's with the air molecules when they cross the fins. Higher efficiencies also due to improved evaporator design. So if we look at this design of this Daikin unit, a cross-flow design has been created to increase air turbulence. So if we look at this typical cross-flow design, which Daikin has incorporated compared to conventional parallel flows, this allows for a lot of destratification of the air and nice mixing of the air molecules so they can release their energy onto these cold coils and therefore cooling the air. Further advancement is the way that the heat exchangers have been fabricated. We call it what we call secondary flanging. So if we look at conventional secondary flanging, we will see that the spaces, the heights of the fins are different to single flanging. So single flanging is just sort of the letter L, and with time these things eventually loosen and they lose contact surface with the copper pipe, and when you lose surface you're reducing the surface area for delta T for your heat exchange, and this is just pretty much poor build quality, and you also get uneven spacing on your fan pitches per inch. So it's not a nice even spacing, and these do work loose. So the factory have done this double flanging to prevent separation of the working fluid pipe. Low sound levels, advanced airflow design. As I mentioned already, we've had the enlarged impeller design, results in a lower fan speed. Lower fan speeds mean more energy saving and also noise reduction. And there's further noise dampening being incorporated within the housing, especially this dampening on the top cover, which has been fitted with sound absorbing material. We have the various options of bottom return air or side return air options on the units, depending on the gymnastics and space availability of the ductwork. The units also can come with heating elements. We go from 1 up to 5 kilowatts, 5 kilowatts generally on the 14 kilowatt units. Very importantly, choose the heater safety. We have 2 heater safeties. The first will be your bimetal switch, which will typically open when the heater runs away, if you want to call it that, and as it cycles on and off, it will pulse. With the bimetal switch at 105 degrees plus or minus, it will open and break, open and break. If this ever fails, the bimetal switch fails within here, we have a fusible link that will open at 130 degrees, which is there. It's a little fuse in series with the supply, or if it pulls more than 10 amps, which these are pretty much related. At about 130 degrees, the 10 amp wire will go open circuit, cutting the supply to the safeties. Further to that, once the fan coil is turned off on the thermostat, the fan will continue to run on for a further 60 seconds after the electric power down. That is just to dissipate any heat, and also so you don't sort of get that burning smell in the air. On our drain pan options, it comes with the standard 7mm polyethylene foam, or it can be selected the 6mm Armorflex option from the factory. Drain pans, we can also extend them for 100 or 200 mils. These are always advised to have extended drain pans because your valves sit above these and your valves will always sweat. Valves could typically be having an on coil of around 6 degrees. The temperature in your sealing void could be in the mid to high 20s, even peaking at 30 degrees, and it's going to create a lot of dripping condense. So we always advise to go for the extended drain pans as an optional extra to prevent dripping in the ceiling and damaging ceiling boards or ceiling tiles. Optional air filter nets as well as aluminium grating can be further optional extras on these ducted fan coil units. We also offer two-way valves as well as three-way valves. These are obviously going to be a decision depending on the strategy and the hydrodynamics of the system. So if we want three-way valves, we would typically select this valve for designs where there's constant speed pumps in the plant room. A three-way valve will always maintain a constant volume or mass flow rate of water. A two-way valve, these are often also on very large systems, but these are for designs where you have variable speed pumps in the plant room and where constant volume of water isn't necessary. So this is like an on and off, there's no bypass of water. So it depends on the strategy. We can offer both, either the two-way valve or the three-way valve with the electronic actuators driving the valve stems. What kind of control can we offer on these units? Now, standard AC induction motor fan coils, the range of thermostats we have are 3. The conventional, let's say electromechanical, we have this offering where you can connect a infrared remote controller as well onto the system, this AC130, or we offer this LCD display which is already configured for BMS connectivity. If the inverter model fan coil is selected, we offer this remote control. It comes with BMS adaptability as well as a 3-speed controller, or we offer a 0 to 10 volt signal, which offers optional linear fan speed control. So this will be gradual. It will just be linear up and down, but you'd need a third-party controller to drive the fan for the commutation. So if we look at remote control options on larger systems for the non-inverter fan coil units, these are typically, you can have valve driving on all three remotes, as well as fan speed control. And this is, as mentioned, this RS485 network for BMS connectivity comes on the AC 2982 remote controller. If we want to go for centralized control, a third-party centralized controller, for example, a network controller, depending on what the third-party controllers can generally control up to 32 fan coil units. And very importantly, an AC 290 controller must be used for every indoor unit. That is because we daisy chain the RS485s. Shielded twisted pair used for connections. The communication cable between the central controller and the furthest unit can be up to 1 kilometer. If going for the FWWC, which is the fully inverter unit, then the BMS control can be connected straight to the central board on the fan coil unit. You don't necessarily need a remote to link the RS485 network into per fan coil unit. If we look at if we go for the inverter model, you would require this LCD controller. And here you can also see we can offer valve control, but this is also all control of the circuit board of the unit. Here we can see the advances of the circuit board built in on the main circuit board of the inverter unit. And here's the landings for hot or chilled water valves, which is your 2- or 3-way valve. This is where we pulse through a relay to drive your heater. Pulse your 220 volts. Here's your conventional 3-feed speed controller. This would be your 0 to 10 volts for modulating valve. Your BMS controller. So you could have your 2 RS485 communication ports. So the unit can satisfy RS485 wired control and BMS centralized control at the same time. You have a room function card here, ideal for hotels. So your hotel access card, or you could even have like your window kill switch, your make or break. If they open a window, the fan can stop on this unit to not waste any air conditioned air. Here is your 0 to 10 volt linear signal. If this is selected though, the room card and modulating valves will be invalid. So you won't be able to use your 0 to 10 and your window card. This takes priority to drive the fan motor. And we have a return air sensor. Can be selected to detect your return air, which then will obviously through proportional integral calculation, the unit will make judgments so that the air temperature can be better met to expect the desired set points. It also has to be installed if you want to use BMS options. And then lastly, we're going to look at some reference sites where these chilled water fan coil units are already installed around the world. If we look at just some hotels in Dubai, 600 fan coil units in the White Swan Hotel. Commercial centers, up to 100,000 units being installed on this project, and 1.1 million units being installed in this plaza in China. So some very nice orders that came through for Daikin. In residential buildings, we have 4,100 units installed in these towers in Hong Kong. And the Palms, which are that forecast around 20,000 units. This is still under construction, but they at least 20,000 units of this ducted range. So these are some very high profile projects where the clients have chosen the Daikin ducted chilled water fan coil units. As well as some airports in Beijing, 911 units, and 2,270 units installed on this project. So yeah, we'd like to thank you for the participation. If you have any queries or questions, please feel free to ask them. If there are any questions that pop up at a later stage, please feel free to email Daikin, and our applied salespeople can gladly assist. And also these videos will be uploaded on the Daikin YouTube channel. It's Google YouTube and then type in Daikin South Africa, where you will see, besides our product presentation videos, we have a lot of technical videos that can be looked at, from the basics of engineering fundamentals to the more advanced on hydraulics as well as electrical. And we also have a channel where we're promoting any service and field related queries. We have a lot of videos on know-hows on how to access different parameters, different fault finding. It's all on our YouTube channel. So click on subscribe on our YouTube channel to be informed of any new Daikin videos, be it training or technical support or new products, and click like on the videos. And yes, thank you. We'll take any questions now.